Hello everybody, this lesson is with simplifying rational expressions. So a rational expression is just a quotient of two polynomials. And you'll want to remember how we have factored polynomials. So breaking apart, looking for difference of squares factoring pattern, or think of with a trinomial, multiplying where you factor out using the FOIL method. So think of the FOIL method backwards. So for example, for this one, if I were to factor this, I can see in my numerator this is difference of squares pattern. I'm subtracting two perfect squares. This would actually factor out to x minus 2 and x plus 2. Difference of squares factoring pattern, you're always listing the square roots of each of these, but then one binomial has to be subtraction, the other one has to be addition, because if you were to check it by foiling back, that middle term needs to cancel out, so they need to be opposites. So a minus 2x plus 2x would cause that middle term to cancel out. And then in our denominator, I have a trinomial. If you think of factoring that to two binomials, x squared is multiplied by getting x times x. And then 2 would be 2 and 1. So I need the two factors that multiply to equal this number, but add to equal this number. So 2 times 1 would multiply to get to 2, but add 2 plus 1 to get to 3. Just real quick, going back with this, then the rest of this to simplify, you cross off what's in common. So in order to identify what's in common, you need to keep these terms grouped as a binomial. So you don't want to start crossing off this x with this x and this 2 with this 2. You want to cross off the entire binomial that matches. So this entire binomial, x plus 2, crosses off with this entire binomial, x plus 2. So you're crossing off the entire chunk, and then you're left with, in our numerator, x minus 2 over x plus 1. So keep this combined together as one term, this x minus 2 and that x plus 1. We cannot then cross off x and x to get negative 2 over 1. You have to keep this binomial grouped because it's separated out by addition or subtraction. So this would be our simplified answer. Also part of this is thinking about restricted values. And a restricted value is just any number that would cause our denominator to equal 0. Because we can't divide by 0. It's not possible to divide by 0. So we have to identify those values that are going to make that happen. What's going to cause our denominator to equal 0? So in this example, to identify that restricted value, in my denominator, I have x minus 3. I need to figure out what's going to cause this to equal 0. So some of you might be able to see right away if I plug in 3 for x, 3 minus 3 equals 0. It's also helpful to know you can just set that equal to 0. And if you were to add 3 on each side, you would figure out that x would be 3 when it equals 0. So my restricted value, x can't equal 3. Because that would cause that denominator to equal 0. Another example, I have x squared minus 4. So before you just say, oh, it would be 4, you have to factor that denominator. So this would actually factor to, this is difference of squares, so x minus 2 and x plus 2. So looking at this, I can see that x can't equal a positive 2 or a negative 2. But if it's not as easy to see, again, you can set those equal to 0. So x minus 2 equals 0. By adding 2, you'd find that x, one value to cause it to equal 0 is 2. Same thing with the x plus 2. So x plus 2 equals 0. If you subtract 2 on each side, one value then is x equals negative 2. So here are the restricted values. X can't equal 2 or a negative 2. You're looking for the values that cause that denominator to equal 0. So combining that with simplifying rational expressions, your first step for simplifying, factor everything out. So you want to look for greatest common factors. What do those two terms share that you could factor out? You want to think of difference of squares factoring pattern. So we've gone over a couple of those already, factoring difference of squares. And if you're given a trinomial, factor it out. Think of it as using FOIL, but backwards. So you need two binomials. In this example, our denominator is already factored out, but our numerator is showing difference of squares pattern. So this would actually factor in the numerator x minus 3, x plus 3. I want that middle term to cancel out. So my two binomials are opposites. And then we have in our denominator 2x plus 1 and then x plus 3. Before you cancel anything out, identify those restricted values. So 2x plus 1 equals 0. If you solve that, subtracting 1, you'd have 2x equals a negative 1. And then dividing by 2, x can't equal a negative 1/2. So there's one of our restricted values. The other one, x plus 3 equals 0. If you subtract off 3, x can't equal a negative 3. So we'd list negative 3 also. Once you've got your restricted values before factoring, then you can just simplify your rational expression. So over here, if we simplify, my numerator has an x plus 3 and my denominator has an x plus 3. These two would cancel each other out. It's just like 2 divided by 2. They cancel each other out to be 1. And we're left with x minus 3 over 2x plus 1. We can't simplify anything else out because these are grouped binomials. Another example. So again, think of factoring out greatest common factor, look for difference of squares pattern, or factoring trinomials. So in my numerator, I have a 3x and a 6. Both terms share a 3. So if I divide out a 3, I'd be left with x plus 2 in my numerator. In my denominator, I've got a trinomial. So I'm going to factor to two binomials. So x and x. And I need two factors that multiply to equal 6, but add to equal 5. So 2 times 3 is a positive 6. 2 plus 3 is a positive 5. So this would factor to x plus 2 and x plus 3. And then you simplify. So this cancels off with this one. And you're left with 3 over x plus 3. And again, you cannot cancel out this 3 with this 3. This is a grouped value. You can't break it apart. One last example. So this one, remember your different factoring options. In my numerator, I see subtraction and two perfect squares. There's difference of squares pattern. So x minus 6, x plus 6. So you're taking the square root of each of these. One is subtraction, one is addition. In my denominator, 2x squared minus 12x. Both terms share a 2x. So if I divide out a 2x, you're left with x minus 6. And then crossing off what's in common, x minus 6 cancels off with x minus 6. You're left with x plus 6 over 2x.